Can you hear me now? That's embarrassing. I think Yep. I used to do, my microphone would automatically turn on when I changed scenes, but now I have a toggle button, and I forgot to use it. Thanks for, thanks for letting me know. Now that you mentioned that, I also forgot to put the Twitch overlay up, so I wasn't seeing your chats coming in on my screen. I saw them coming on my phone, but now it's back. All right, cool. So that must have been a confusing start. Yeah, basically I'm just cleaning up some code from my streams yesterday. I'm making a game engine, and I have had to make some modifications to the way that my OpenGL contexts were created, because I needed to use a more modern way, for a couple of reasons, but at the moment it was just so that I could use RenderDoc to diagnose an issue. And now I'm committing that stuff, just making sure everything looks nice and slick before I commit it. And then I will move on to doing more game module reload stuff. How's your day going? Yeah, this looks all pretty good. Yep. And yeah, I think that's ready. I'll go ahead and stage that. And window.cpp went through some changes as well. There we go. Yep, that's looking smooth. I need to make some changes to the macOS layer, because we don't have set width and height anymore. We just have set size. Boop. That's ready to stage as well. Cool. I'll come back to texture binding stuff. I'm not sure that that's relevant to the change I'm committing. Yeah, this was something else. All right, good. Window.h. Yep, these changes are good. Boop. I need to have window be a friend of the graphic system in order to make this call available to window. And yeah, we got editor play cleanup, frame buffers and stuff. This stuff I will add separately. I will add this now. So handy feature of VS Code is that you can stage selected ranges, so you don't have to commit the entire contents of a file. You can just commit the things that are important for that commit. And this is stuff I'll commit later. All right. Yeah, and that's the file I was just looking at. And yeah, that's a later thing as well. this needs to change. So many changes in one commit. You're not scared of breaking something? Nah, I'm pretty. I've gotten into a pretty good groove with making sure that I'm not that I'm making commits that make sense. And to be clear, these are all the things that I'm adding. They are all one change, and that is the transition from the old OpenGL context creation code to the new. And that had consequences that broke other things, and then I had to fix those things, and then those things are going in to the commit because of that. But yeah, I've been kind of working on this big refactor project. Not all at once, but I've not been kicking issues down the road as I go. So I've been making the changes, and then later on I'll either just commit them all at once if that's easier, or I'll stage them as separate commits. In this case, I'm staging this as a separate commit because this came up while I was working on something else, but this is important enough to be its own commit. Yeah. Oh yeah, then there's the changes to GLAD. I had to reload GLAD to get some of the extensions I needed for this, the WGL stuff specifically. I'll need to review that in a minute because I know that there's extensions that I added that I'm not using. Yeah, but realistically, yeah, you're probably right. When I'm working on, it would probably be better form of me if I worked on one thing and then if I go to work on a different thing, do that on a different branch. But I'm having to overhaul so many things all at once that I think that branch hopping would be sort of it would just take too long. And I'm working on this solo, so it's not like I'm gonna run the risk of having somebody else bump up against my changes. And all of this stuff was related to this is related to the input system cleanup that we did a couple streams ago. Okay. Cool. I think that is it for this change, and then we'll move on. The only other thing is that I need to get GLAD corrected. So let's go to the website. Whenever you make a loader from GLAD, one of the cool things that it does is it puts the link to the site that preloads all of your options directly in the code. So if you're like in any modern code editor, you can usually just control click it and then it'll pull up the generator with all the settings that you had used to make the thing work. I had misread some of the code from GLAD itself regarding the extension string extension. I thought it was saying that it needed both, and I was like, why would it do that? But it doesn't actually. It only needs one, so I can get rid of the ARB extension string and just use the EXT extension string. I do need the create context profile. I need the pixel format. I need the extension string. Oh, but the pixel format, I only need one of these, I believe. So I'll get rid of the ARB one. Yeah, and interestingly, the create context is ARB instead of EXT. I'm not sure what that's about, because this is apparently like a fundamental thing since OpenGL 3.2. But yeah, I think we're all right there. So we got the create context. We need the create context profile extension in order to set up, in order to say things like I want OpenGL 4.1 in core. I need the extension string to load the WGL stuff. I need the pixel format to specify using the new create context. So this is actually required of this extension, but for some reason they make you do the extensions one by one, which is probably okay, but annoying if you're new to this. Let's generate the new GLAD. And I'll install it and make sure that it works. Copy, and then we'll go to, here we are, engine vendor GLAD source. Wait, that's the source folder. Engine vendor GLAD, and then paste in and replace. All right, and hopping back in, we see that the code is updated. Let's confirm that that compiles first. So I'm pressing F7 to compile everything, and almost immediately we've got a problem. What is that? An issue from glad wgl.c, which I wasn't really expecting. Okay, it is explicitly requiring the ARB version of this. So that's annoying, but whatever. So this is from the pixel format extension. I can't use this apparently. I have to use the ARB one. There we go. So we got the ARB pixel format, and then we're going to get rid of the ext pixel format. Maybe I have to use ARB extension string as well to make everything play nice. I mean, they're the same. they should be anyway. They just have different names. I'm just going to make everything ARB instead of... hey, Miguel, how are you doing? I'm going to make everything ARB instead of using any of the ext stuff, because it seems like the GLAD loader seems to fight with itself if you use the ext version of something. What do I think of Vulkan? I think Vulkan is nice. I have never used it. It is very complicated, but those complications lead to better code. I think eventually I'll probably transition to using Vulkan on Enterprise, or at least add it as an option in addition to OpenGL, but for my purposes, as somebody new to graphics programming, I'm not really a graphics programmer. I'm sticking with OpenGL, but eventually Vulkan is something I'm going to be looking into because it's got some perks that I like. And it's totally doable to do a high efficiency, high performance, super amazing graphics renderer with OpenGL. So it's not like I'm limiting myself very much by using OpenGL. It's just that if I was gonna do like really big stuff, I'd probably want to switch to using Vulkan or DirectX. Probably Vulkan because on Apple machines you don't have first-party support for Vulkan, but at the very least you have second-party support for Vulkan, because at least Kronos Group, they have the Molten VK or Molten DK or TK. I think it's Molten VK. Yeah, Molten VK, which does the port. Do I have an ongoing to-do list? How much of your end versions is completed? I do have to-do lists. My preferred tracker is Trello, and there's a lot in here. There's a lot of stuff. It's a game engine. It's complicated, but generally, if there's a thing that I need to do, like before I do a commit, I will do a yeah. I know. Well, if there's something I need to do before a commit is submitted to GitHub, I will do a little comment and say to do. Or if there's something that's just like very hard to separate from a line of code to say this thing needs to be fixed for this reason, then I'll do a to-do comment. But for the most part, if there's a feature that I want, or a situation that I anticipate needs fixing, but but right now it's not the time to do it. I'll add it to the appropriate Trello board on here. But yeah, there's a lot. Anyway, let's paste the new GLAD. And then in here, if I press F7, let's see if that resolves anything. Trello, yeah, Trello is good. It really just got to use whatever works for you. I particularly like Trello because it's flexible. Yeah, you can. It's basically you can do an ordered list in each item in those lists. Like if I take a look at this, or hang on, let me find a better example. Like this, interpolation algorithms. This is something that I anticipated needing, so I threw the idea on the board, and I can add a checklist for all the things as I go, so I can check or uncheck whether I've done a thing on that card, and then I can drag things from board to board as necessary. So it works for me. I know a lot of people use it, but there's other solutions out there. It's just a matter of what you're comfortable with. Okay. Oh, okay. Now I'm remembering. So this is stupid, by the way. This right here is really dumb. So what's happening is that this is the OpenGL GLAD loader code. Its purpose is to load the OpenGL pointers, and what it's doing here is that it's checking to see whether I've got one of the WGL extensions necessary for loading WGL code. There's somebody banging on my roof. They're doing work. I hope that's not too loud. And what's happening here is that it's checking to see whether or not these symbols have been loaded. But because I haven't loaded the other symbol using GLAD, because I'm only using one of the extensions, the symbol itself is undefined, so it won't compile. And that's stupid. That is really dumb. So it's either that I include both extensions, which there's no point, they're the same thing, or I have to myself define the symbol somewhere, so that way it's not failing to compile. So I think I'm gonna do it that way. I'm actually going to in places that I include GLAD wgl.c. Wait, no, that doesn't make sense. I would have to actually modify this file, I think, in order to prevent this from occurring. So yeah, it's annoying because like this check it's pretty crystal clear. It's checking to see whether I have one or the other. If this equals null and this equals null, return 0. But yeah. Have I tried null pointer instead of null? I think if this was my code, then yeah, I'd probably be using null pointer instead of null, because that's a type safe thing. But this is the GLAD loader. It's generated by GLAD on their website. So I really don't want to be modifying that code because it's supposed to be generated to suit my needs. So what I'm gonna have to do instead, and I really don't like that I have to do this. I'm just going to add both extensions. So I'm clicking the link to reopen. So this is the list of extensions that are in my generated loader. Let me go ahead and add extensions string, the ext version. So now there's both, but yeah, I guess that's how it's going to have to be. All of this funky business with getting the extensions to work correctly with GLAD is making me think I should just do it myself. I am almost there. I think that when I get to doing some of the real-time, like live window changes, things like giving the player the ability to toggle on and off double buffering and stuff like that. When I get to that point, I'll probably revisit the question of whether to use GLAD, but for now, I'm just gonna put up with it. Are you near a minimum viable product? Your scope seems really wide. Yeah, the scope is a game engine. This has a very wide scope. I am pretty close to a minimum viable product. And to be clear, the Trello board does not represent my minimum viable product. My minimum viable product in this case would be an editor that can generate a game project, and the game project can execute code in game states, which is a thing related to my paradigm, and it can create game systems, which is a thing related to my ECS model. It doesn't. My MVP, believe it or not, doesn't even include a renderer because the framework is more important. You may want to, for example, make your own renderer for your game, and my framework is designed to make that. It's intended to make that simple, if that's what you want to do. But yeah, I'm getting really close to having some fun stuff going on. I've got, the framework set up so that way it can load and reload game projects. But that reload part is what I'm going to be addressing once I've fixed this and committed GLAD and the changes to how I load my OpenGL context. Yeah, I've been going hard at the engine for a couple of, like a week and a half or 2 weeks now. There we go, now it's building correctly. Cool, there's the game. Here's the game being run as a DLL. Good. And then let's run that editor. And there's the game running in the editor. Oh, thanks for the follow, Brains Man. You are breathtaking. Cool. And that's working. Though there's some quirkiness going on with if I click stop while it's running, there's a problem. I'll probably take a look at that next. But yeah, let's go back to the source control. And now we are ready to add the new version of GLAD. Here we go. And then the CMake lists as well. We had to add the GLAD WGL.c to the build. And then KHR platform was updated, though the update really doesn't have anything to do with the game code. It just happens to be. I think this just happens to be because we're using a newer version of GLAD. Are there version notes in here? I don't know, there might be, but we'll commit it. And the GLAD headers as well. How do you use reflection? How do you approach reflection in C++? That's a fair question. I haven't gotten there yet. I'm going to have to when it comes to the editor, because there's places where you need to have information about the things that you plug into the editor available. But reflection, like, probably the most reliable approach for reflection in C++, and the approach that game engines like Unreal Engine use is they use a macro to wrap things that need to be reflected. So you might use a macro to declare or define a function prototype, and then that macro has the ability to take the actual text, or the preprocessor has the ability to, has the ability to take the actual text name and then treat that as a string and store that somewhere. And that's something that I'll deal with later when I get to it. But yeah, it's not going to be as elegant as a language that supports reflection. And reflection is one of the things that people really love about C#, and why a lot of folks like to script things in C# in their game engines. I'm not going to go that route. I'm going to try and make it work in C++. But that's a problem for tomorrow me. Okay, I think that's that. There's a lot of little file changes here, but they're all actually in service of the same problem, which is transitioning to using creating a dummy window, using that to load the WGL stuff, and then using the WGL stuff to create the real final OpenGL context. Cool, so let's add that. Transition to WGL, create context attrib, I think that's what it is, ARB. Double check that that's how you spell it. Attribs ARB, okay. Yeah, I'm just gonna say like that. Boom, commit. Alrighty, now we're kind of back up to speed. So that was a big old sidebar here we go. That was a huge sidebar from what I was actually trying to do, and I was trying to get everything cleaned up correctly between opening and closing projects and playing and stopping play in editor. This is one of them. I think this is where I'm going to start. So what just happened was I clicked the button on the title bar to stop playback, and we've got an error already. What is the error? Graphics load texture. Okay, that's not it. Okay, so we're trying to read a location that is out of bounds. Let's go to the call stack, review where we're at. Okay, so this is happening when we're cleaning up the frame buffers. So we've clicked stop play mode. Oh, hey man, yeah, I did. It was something stupid. It was a little while after I got off that last stream where you and I were talking about it, and it turned out to be that I was accidentally resizing the viewport to 0, and this had to do with the way that I was tracking frame buffer widths and heights. The default frame buffer I would set to a 0, size, which in my code I meant that to represent the dimensions of the window. And so yeah, but yeah, RenderDoc actually wound up helping with that because I went through, and after I kind of figured out how to navigate my way through there, I was able to identify that there was a viewport call that was saying 0 width, 0 height, so it wasn't rendering anything to the textures. But that's all working now. All right, so here we click the stop button to stop play in editor. We call editor play cleanup. Editor play cleanup presumably went to cleanup. Oh no, this is the game code editor play cleanup, right? So this cleans up anything that the game project wants to clean up for play in editor. This invokes everything we care about for the low-level systems, and that's where we run into trouble. We do time, events, input, graphics, get all those cleanup calls, and then state manager, which is actually what I was working on before I had to take that sidebar with RenderDoc. Hang on. State manager. Graphics. Why is it pointing to... We have a graphics editor play cleanup. Oh, this is happening in graphics, not in state manager. Okay, so in graphics we invoke clean frame buffers, and at this point we should have frame buffers created in editor play. if there are any, which I don't remember off the top of my head. Let's take a look at the test state code. So this is the simple state code that sets up my 3D camera and puts the sprites in the scene and renders that text, that whole thing that we were seeing when I was using Plane Editor. Okay, I do create a frame buffer. I don't use it though. This must have been left over from when I was testing post-processing effects. So this frame buffer presumably would be deleted by the frame buffer cleanup code. But this would have been invoked first. So okay, here's the problem. So what's happening is that the test state, so the gameplay code, is trying to clean up after itself as it should. But that method for deleting the frame buffer, it doesn't consider whether we're in play mode or not. So if we are in play mode, I need it to remove the frame buffer from the tracking list, which was FBs created in editor play, this guy. We need to remove it from that list. Huh. Okay, so the first thing is that I'm going to need to change which container I use for these handles. Before, what I was doing is I was using a vector, simple, you just push into it, and then you just go through the whole thing at once when you need to clean up after the game. But now that I know that game states will clean up after themselves, now that I've realized that, this won't do, because I need to have random deletion. So I'm going to change this to be a set. Or actually, maybe I should make this I said set. I typed list. Maybe I should make this a set instead of a vector or a list. A set is basically a map that has no values associated with the keys. So you can very quickly check to see whether something is in the set. O log n time in the worst case. And then you can remove from the set really easily. I think I'll use the set rather than a list. And now I've got to go through all the places where I was using it. So instead of pushback, we will use insert. Again, and this doesn't have to be like that. So in this case, what are we doing? We are searching for the frame buffer we're going to delete inside of that stack. Okay. Wait, hang on. Is this the code that I was looking at before? It was, yes. Okay. Yeah, so it is searching for the frame buffer that we requested to delete inside of this list. And then it presents an error if it's not in the list. Oh, okay, so we actually are deleting. So that, I thought I had a good beat on the problem, but I guess not. Let me finish though making this a set, because it's gonna make this code a little bit cleaner. So instead of using an iterator like that, we'll say if fb's in editor play.count, and we'll check for, I think the parameter was just fb. Yeah, fb. So if FB is in the set, or if it's not in the set, sorry, then we will generate this error. Otherwise, we will remove it. And I think we use erase on that one. Yeah. Yeah, and then we pass in the key. Okay, it's a little bit cleaner to read. Okay. Okay, and this code still holds up. You could still use a range base for loop for all of the keys inside of a set. Awesome. So, I still think it was best to change to using a set, but apparently that wasn't the issue. So let's go back to debugging. Take a sip of my water. Alrighty. So we got plain editor working. Escape works fine, but if I click stop on the top, debug assertion failed, cannot increment value initialized, blah, 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 blah. We'll hit retry because that'll bring us into the debugger. And this is occurring, yeah, so this is where we were before. So we're going through every frame buffer in FB's created an editor play. Oh, okay, hang on, I think I've got it. So what's happening here is that when we go to clean up, we are looking for every frame buffer that was created in editor play, and then we are calling delete frame buffer on it, and delete frame buffer itself accesses and edits the contents of FB's created an editor play. Okay, so that's our problem. We are modifying the set while we are iterating through it. So that's bad news bears. So what I'm gonna do is I'm just gonna do I'm just gonna make another set. I'm gonna duplicate FB's created an editor play, iterate through that, and then make the change. That's the simplest way to handle this. And then we can do that. And I'm just gonna, that's bad code, but or bad style, but I'm just gonna confirm that that fixes the issue before I think of better names. There we go, and F5. All right, moment of truth time. I click play. Oh, thanks for the follow. Welcome in. All right, so moment of truth time. I click stop instead of hitting escape. Okay, we still got an issue. I thought we had it, but maybe not. Graphics delete frame buffer FBH does not exist, and that's because the frame buffer handle FBOs still exists. That's interesting. Let's go back up the call stack. That's actually a different point of failure than before. So it sounds like we fixed the first issue, but there was one farther down the stack that I skipped over. Okay, so now we are in cleaning up the states from the state manager. Okay, so now this is an entirely different system. So we are cleaning up. We're calling cleanup on the test state. We're calling delete frame buffer. Oh, right. Okay. All right. So this is being called after we have already called delete frame buffer from the low-level systems. I don't think I was expecting that. Let me go back to this level. All right. So this is where we clean up everything from editor play. Now that I'm looking at this, I'm realizing I probably should put state manager up here. State manager is the system that manages the global state machine. So you can think of like a gameplay situation as a state, and then from there, you might transition to a loading screen state, or from there to a menu state, or you might even push a state on top of the other state. So you have a state that represents your gameplay code, and then you push a pause menu state on top, and the gameplay still exists below it, but you are temporarily switching control to something like a menu. So this is a gameplay system, basically. This is a behavioral thing. So this should probably be cleaned up before time events input and graphics. And actually, I think in my head, I was thinking that I was going to clean these up in order, but actually I need to clean these up in reverse order. So I need the behavior systems, then I need the interface systems, and then I need the core systems. So state manager and scene manager up here, graphics, audio, and input here, and then events, time, and file down here. So let's do that for the moment. We'll stop, press S7, rebuild, confirm I didn't break anything. There we go. And play. Seems to work okay. And if I press stop, aha, okay, bug fixed, apparently. So play and editor is working. Escape kills the play and editor by terminating the last state in the state manager. And then if I click stop, instead, it kills it by telling the engine that we are killing it, and then it cleans up the states. So I think we're in a good spot with that. Perfect. However, I'm not going to go to committing that change because that's only a problem that was created by the task that I'm trying to complete. So let me go back to where I had that silly fix. Auto dupe, here it is. Thanks for the follow, what's up? Yeah, so this here was simply so that I'm not modifying FB's created in editor play while I'm iterating through it. However, auto dupe is a stupid way to do that. So I'm going to go ahead and make sure that I say we are doing an STD set of frame buffer handles, which I have an alias for. That's FBH just within this file because I use it all over the place, and typing EP graphics frame buffer handle all over the place is a lot of text. And then instead of calling it dupe, we'll call what should I call it? I guess it would be FB's to delete temp. Yeah, I think that's pretty clear. Cool, and then we iterate through. Yeah, naming is hard, yeah. I don't know, I think I probably think too hard about naming, honestly. I'm getting better at hacking together stuff and then worrying about the names later, but I have to take I have to be especially careful about what I name things, because eventually that's going to be stuff that other people are going to have to read. So a game developer using the enterprise engine, they need to understand what the API does when they go to try to use it. So I need good naming. Cool. So I think that's that. And actually, I think that wraps up the cleanup code on the frame buffers. Let me open up my list. Here we go. So I've got a list of things that I needed to reset, and my plan for like where and when they should be reset. Basically just a list of all of the state the engine has, excepting of course game code, but that's we'll put that on the back burner for the moment. So we already have timescale being reset. So if you are running a game that is in the middle of a slow motion effect and then you hit stop, it will automatically go back to timescale 1. That's good. I have subscriptions being purged. So if you go to subscribe to a event during a game and then it gets killed before it has the chance to unsubscribe, that subscription won't be lingering when you go to hit play in editor again. So that's done. I believe we finished on input, if I'm remembering correctly. Input.cpp. Yeah, we got a considerable amount of traffic today. I rarely get more than a couple of people in at once. How are y'all doing? Here we go, editor play cleanup. Yeah, so we reset all the controller bindings, we clear the context stack, and we unload any newly loaded context definitions. So yeah, cleanup is done on the input. Those were the 3 things. Modifications to the frame buffer stack. Right, so this is what we just did. When you're in Play in Editor, you can have either a state or a system push a frame buffer. So for example, if you're doing a UI, you might have a reason to render to a texture and then put that texture somewhere else in the UI. So you might, in your state code, push a frame buffer, render, pop the frame buffer, render that texture. And if you forget to pop, then I need to clean up after you. And so that's what we just got working. And then when we go to unload the project, we need to pop all of them. And I believe that that's done in frame buffer cleanup. Oh, no, it's not. Okay, hang on. That's something I need to do. Yeah, so we're gonna need to go through and clear every single frame buffer that's been pushed. Yeah. So let's do that. I'm just looking through all of the state that we have to worry about. We have to clear the FB stack and the viewport stack. That's the internal engine tracking of which frame buffers have been pushed and what the current viewport is. I need to clear out descriptions of frame buffers. I need to clear out, I actually need to destroy the OpenGL objects, the actual FBOs. And then I have a system for recycling frame buffer handles as well. That state needs to be cleared. So I'm just going to copy all of this. All of it, Control-C, head down to cleanup frame buffers. And this is the cleanup code that's invoked when you have closed your project. So not just stopping Play in Editor, but you're switching from one game to another game. And we need to reset all this stuff in a smart way. So first, I think I can just do, on all of these, I can just change them. I'll do, get rid of the static, get rid of the declaration stuff. And then set next FB handle to 1, that's the default. Returned FB handles, we'll say .clear. And then, what's this one? It's a set, yeah, so we can say .clear as well. Here we go. In dynamic builds, we track the frame buffers created during editor play and pushed since editor play. We can just set these back to their defaults. So on this one, we just call dot clear on it. And on this one, we just set it back to 0. And I should probably keep the labels so I can quickly, at a glance, identify which state I'm dealing with. Frame buffer handle stuff, done. And then the actual OpenGL stuff. So this map of FBOs, we're going to need to iterate through it, and then actually call the OpenGL code that deletes it. So the FBO is a map of frame buffer handles to GLU ints, and the GLU ints is what you actually provide the OpenGL API for frame buffer manipulation stuff. So what we'll do is we'll do for, and we'll do this as a range-based for loop, which I particularly like, especially with C++ 17's structured bindings. So we'll do for auto reference. I might as well make that const auto reference. The keys are the handles, and then the values are the OGL FBO. I'll say FB on that. No, I'll say handle. That's probably fine. I'll change my mind later. But for now, let's get the code working. So we've got every handle and every OGL frame buffer object name associated with that. And now we need to do some OpenGL stuff. I have a macro defined that does error handling for OpenGL. Again, I'm targeting OpenGL 4.1. Which means that I don't have the ability to register error callbacks, which is normally how you would detect or handle an error if you screw up something on OpenGL. In my case, I have a macro that actually just does the check and then handles it appropriately. So we wrap that, and then we go gl delete frame buffers. And what does that accept? I haven't used this for a while. Here we go. Oh, that's interesting. So we actually pass in an array of frame buffer object handles. So I might be able to submit all this at once. Now, being that we're storing these in a map, I don't have the ability to just like get the raw data here and pass it in. But what I could do, I could assemble an array and then pass that array to gl delete frame buffers. I like that idea a fair amount because that's a faster way for whenever you have the ability to batch up stuff for OpenGL. That's good. So what we'll do is we'll do make sure that I'm using similar types. GL size I for the array size. So FBs to delete count equals 0. And then GLU ints for the actual handles. So we'll say we'll make this a vector. So std vector GLU ints, and we'll say FBOs to delete. And I should name this a little differently. FBOs to delete count and FBOs to delete. And the reason why I'm using a vector here is because I can simply call FBOs to delete dot data, and that'll get me an address to a continuous block of data representing the frame buffer handles. So yeah, easy enough. So we're going through every single one of these, and we just basically go FBOs to delete dot pushback OGL FBO. Cool. We don't actually need the handle in this case. My style is to use an underscore to represent structured bindings that I'm ignoring. Technically speaking, that's still a valid name. It's not a keyword or anything like that. But this kind of indicates to me that I'm not using it. And then we can, well, we need to increment. Actually, we don't. We don't even need GL size I FBOs to delete count because that's a part of std vector. So after we're done with this, we pass in how many and we pass in the pointer to. So we'll say FBOs to delete dot size, give us the quantity, and then we pass in the pointer to the data, FBOs to delete dot data, like that. Cool. And so, yeah, basically we're just going through all the FBOs to delete, assembling a contiguous block of memory with all of their handles, and then we call delete on that entire thing. And then we, of course, have to clean up FBOs to delete, or, clean up FBOs, sorry. So FBOs dot clear is the last thing. All right. Moving on, I have an internal representation of the color and depth attachments. That's for situations where I need to pull information about an attachment, but I don't want to talk to OpenGL. These are just maps associating the handle with a thing, and we can just call .clear on them. Like that. Good. That's looking swell. All right. Then there's frame buffer widths and heights, and attachment specs. These can all just be cleared. However, I do need to make a quick modification to frame buffer widths and heights, because I need to actually initialize these with the default frame buffers width and height, which is, you know, it's assumed, like you can because I'm storing the widths and the heights as a 0 when they represent the whole screen. These values will never change, but the way that my frame buffer stack code works is that if you pop the frame buffer above the default frame buffer, it still accesses FB widths at frame buffer 0, which is the default frame buffer. So we do need to insert at 0 a size. So these are just integers, so we would say equals 0, like that. Cool. Those are ready to go. The FB attachment specs, those can just be cleared, like that. Cool. And then the render state down here. Oh, you know what? I have overlooked something. I have overlooked. I have to delete all of the textures. All right, let's do that. Well, let's wrap up these, and then we'll move on. The FB stack and the viewport stack. Again, these need to be initialized with the default frame buffer. So FB stack is just a deck of frame buffer handles. So what we'll do is we will say .clear FB stack dot push back, push a 0 in there, and then the viewport stack is a deck of GLM vec4s, and we need to push the default frame buffers as well. which should look like that. Cool. All right, now back up here, because I had gone through and told OpenGL that I want to delete all of the FBOs. However, they have textures attached to them. A lot of them do. So before we clear color attachments and depth attachments, I actually need to use their values to clear things. Man, I feel like I'm going at 1,000,000 miles per hour. Here we go. So on these, I think that they use a similar call, gl delete textures. Yeah, you pass in the size of the array, and then you pass in a pointer to an array. So what we can do is a similar structure to what we did up here. We would just do a std vector of gl uint. Theoretically, we could reuse this one, but this isn't a place where we care about performance. So I'm just going to do a little bit clearer code by doing separate vectors for each. We'll do FBOs, or sorry, color attachments to delete, and then we will do for const auto ref. We don't care about the key, we care about the attachment itself. And in the case of the color attachments, you can actually attach multiple color attachments to each frame buffer, which allows you to do interesting rendering effects where you render two perspectives, or I should say two versions of the same perspective at one time. Or you can render out data that's unrelated to the graphics, like mouse picking stuff. You can render into a color attachment the integer ID for whatever object was rendered there, things like that. So we don't care about the key. We do care about all of the items inside. I'm going to need to do a nested for loop in this case. So what we're going to get back is a vector. It will be a const reference. At first. No, it's going to be just a reference because I do need to call clear on it. And we'll call this one color attachment list, I guess. And then we'll be getting these out of color attachments. Okay, cool. So now we've got every color attachment list in color attachments, and then we need to iterate through that. So we'll say every GLU int. Oh right, hang on. There's an additional layer to this. The color attachment list, if you can see here, it's a list of not just the attachments, but a pair as well. So it's a Boolean and the actual OpenGL handle for that texture. The bool indicates whether it's a texture, because it's possible for the attachment to be a render buffer instead. So we actually do need to do a branch here. We'll do if color attachment list. Now, yeah, we'll do a for loop, and we'll get both values. So we'll do for const auto reference. We'll say is texture and handle. And we'll get that out of color attachment list. I hope this is making sense. There we go. So now inside of this loop, we're iterating through all the color attachments, all the color attachment lists, every color attachment for that list, and we have a Boolean telling us whether it's a texture, whether it's a render buffer. So here we'll do if is texture. Oh. If it's a texture, we will use gl delete texture. Otherwise, we'll use, I believe it's gl delete render buffer. But more importantly, we are going to need to store those for deleting after the nested for loop. So we're making two lists now. So instead of color attachments to delete, this is going to be color textures to delete. Yep. And then this will be color render buffers to delete. Cool. Awesome. So if it is a texture, then we will do color textures to delete dot pushback. And if it's a pushback, and then pass in the handle. And then we'll do the same thing for color render buffers to delete if it's a render buffer. Cool. All right. So now we've got all of the stuff we need to pass to OpenGL, and we can do that right here. EPGL, GL, delete, delete textures, like so. And then we pass in the number and the pointer to the data. So that's going to be color textures to delete dot size, and then color textures to delete dot data. Boom, boom, boom. Cool. And then we do the same thing for color render buffers to delete, except for instead of using GL delete textures, we use GL delete render buffers, like that. Right? Yeah. Okay. Cool. And then we can finally clear the list of frame buffer attachments for color. And we have a similar situation for the depth attachments, except for the depth attachments can, you can only have one. I held two fingers up, but I meant one and only one depth attachment per frame buffer. So we don't need to do this as a nested loop. We just need to do something like this. Like that. And then we're iterating through depth attachments. And then instead of, here we go. Instead of dealing with handle, maybe I'm getting confused. So we have a map mapping the frame buffer handles to a pair that's true if it's a texture, and then the handle itself. So we need to iterate through. Oh, hang on. Yeah. I need the outer loop, not the inner loop. So let me copy this whole thing down and we'll use it as a template. And then we will use depth attachments. Cool. So we have the depth attachment list. So this is going to be, instead of a list, it's going to be just a depth attachment. So for every depth attachment in depth attachments, we can check whether it's a texture or not. Here we go. So if depth attachment dot first, then we do this. Otherwise, we do that. I wonder if I could break this up even further, because that would be nice if I could do instead of depth attachment dot first. I wonder if I could do is texture. I'm pretty sure you can't nest structured bindings, but I just want to try it. And then handle. Does that work? No, that would be cool if that would work. Basically, I wanted to do. Wait, maybe I have to do this. Does that work? No, it wouldn't work. I wanted to in a single line be able to get the nested variables out, but that's, yeah, whatever. I'll do something similar down here though. I'll do auto reference, and we'll say is texture, and handle equals depth attachment. I believe that would get me what I want. Cool. And now we can use instead of depth attachment first or dot second, we can say is texture and handle. It's a little more elegant to read. And now we need a thing to push these handles into. So I will copy from up above and rename them. And this will be depth textures to delete and depth render buffers to delete. Boop. And boop. Cool. All right, and then in the spirit of doing less work, I will copy and paste the code from above. And we will delete textures for the depth textures to delete, and delete render buffers for the depth render buffers to delete. Cool, and then we can finally delete the depth attachments. All right. Yeah, that's, yeah, a fair amount of code, but hopefully it'll be easy to read when I come back to this years in the future. All right, and I'm gonna say delete FBOs. The comments, I'll make them a little clearer to read. Delete FBOs, delete color attachments, and delete depth attachments. Okay, good. All right. So far, so glorious. I'm going to put this down, deleting the FBOs. I'm going to put that down below the deleting of the attachments. Actually, never mind. It doesn't matter. FBOs, color attachments, depth attachments, and then we're golden. I think that's it. I think that's all we need to do to clean up after the frame buffers. That is for sure a robocall, so I'm ignoring it. Cool. Play. Now, if I close the project, it'll invoke the cleanup code that we just plugged in. And let's see what I broke. Vertex shader compilation failure. What's going on there? Unexpected token at undefined. What am I looking at? It looks like we're trying to recompile the null shader, but we're running into trouble. Yeah, I'm going to hit continue and ignore that for the moment because this is unrelated to the thing I'm working on. This has to do with the cleanup code and shaders, which I started and didn't finish some streams ago. But yeah, if we skip over that, the project still finishes closing correctly. It just didn't compile the null shader correctly. So I should still be able to open project, open up the test game project, hit play. Okay, maybe not. What's the problem this time? The problem is also still in the compile shader source call. So yeah, that's going to be probably next on the list. So unfortunately, I can't strictly speaking test out the cleanup code for the frame buffers that I just wrote because I have to deal with cleanup code on shaders now. Ooh. All right, let's go back to the list. So we have handled the frame buffer stack modifications. We've handled the frame buffer creation modifications. We've handled the viewport changes. Right? Have we? Go back to the editor cleanup down here. Editor play cleanup frame buffers. We clear the oh, actually, we do not need to reset changes to the viewport because by nature of popping the frame buffer. Oh no, that's not true. We do need to reset, so let me do that here. Oh, I'm calling resize frame buffer, not change viewport. All right. I think I need a break. Set viewport to 0, 1, 0, 1. When you use set viewport to change the viewport, I make that API do in 0 to 1. So no matter what the resolution of your viewport is, you can reliably say, I'm going to render to the left half of it. So it'll be, if you do 0 on the L and then 0.5 on the R, then you got the left side. So I can just say 0, 1, 0, 1, and that will set the viewport to the whole enchilada, as it were. Cool. All right. I think I've reached a good spot to take a break. I will come back in, I don't know, like, I'll give myself like 10 or 15 minutes, and then we'll continue on with cleaning up the things in this list. I wonder if I can get through all of these items this stream, because if I could, then that would mean that tomorrow we get to do fun stuff. Actually, today's Friday, isn't it? So on Monday we get to do fun stuff. All right, I'll be back in a little bit. Alrighty, I'm back. That was a little longer than I thought it would be, but had a spot to eat. And oh, that's interesting. I just realized this is a different bug than when we click the stop button. There we go. All right. Pulling the chat back up on my phone. Okay, what just happened? I clicked the close button while we were in Play and Editor. We are currently in Scene Editor Cleanup in the destructor of the engine runtime. So the engine runtime is being destroyed. We call Scene Editor Cleanup. And then it calls game cleanup, which cleans up the game view, which deletes the frame buffer. Oh, okay. Huh. So the game view is the little window that does the play and editor. And it creates and destroys a frame buffer using the Game Engines API. In order to handle, to wrap the graphics rendering so that it'll display in the window instead of to the default frame buffer. This allows the game to run as normal within the bounds of the game window. And what's happening here is that I am quitting the application while Play and Editor is in place, and we are calling delete frame buffer after everything's been unloaded from the game project, after it's been completely disconnected, and the engine has been destroyed. And so this delete frame buffer is actually unnecessary. I didn't think that would be the case, but it is. Yeah, because it's this cleanup will only be invoked when the application itself, where the view closes. So I haven't quite got to the point where I'm doing where I'm closing the game view in the editor, and I don't know whether I'll get there, but yeah, for now I'm just going to go ahead and get rid of the cleanup code because it's actually literally unnecessary. Quitting the application will be enough. Okay. I hit play, got play mode going, close, and we still got a problem. What the heck? What is happening? Scene Editor Cleanup. We're going into Game Cleanup. Wait, what? Isn't this the code that I just edited? I am confused. I was just in the game view and I just... No, I was in the scene view. Okay, scene view and game view both have a frame buffer to deal with. So let me get rid of those. All right. Back up and running. So where did we leave off? We had just gotten the frame buffer stuff to be cleaned up correctly in the case of Play and Editor and in the case of unloading a game project. we are down to this point where we are dealing with other rendering state, so camera stack, where we push and pop transformations for the perspective that we are rendering from. And then we have blend mode and depth testing and backface culling and all this stuff. This is pretty straightforward, so let's do that next. So if we go to graphics.h, boop, and we can see the API. And this is like the largest API I have in the engine right now. Just the header, just all the declarations and the descriptions of things is almost 1,000 lines. From here, let's go to the camera. Here we go. Push camera is the API call, and it's defined inside of the uniform buffers .zpp because it has to do with updating a uniform buffer that the shaders can access. So that way you can access the model view projection matrix from your shader, and it's going to be reflecting whatever camera you pushed on the stack. Alrighty, so the camera state is stored inside of the per camera global UB data stack up here. That needs to be reset down here with the uniform buffers. So we're going to need to, in Plane Editor, we're going to need to track which cameras have been pushed, and then pop all of them. Pop all the new ones when we leave Plane Editor. And then in the case of regular cleanup, here, cleanup uniform buffers, we just clear them all, and it looks like that's already what we're doing. Cool. And then the blend mode and depth testing changes, I believe that's all in here as well. Yeah, so let's take a look at the camera stuff. I'm gonna change the music to something else. Love myself some Hollow Knight, but there's only so much that you can take of one thing at once. Let's change over to League of Legends Sessions. I'm eventually gonna need to get a subscription to some copyright-free service to allow me to listen to music without copyright strikes. But for now, it's just these couple of playlists that I know are safe. Alright, and I'm going to take a look at the init call, init uniform buffers. I'm specifically looking for any OpenGL calls that I might be making, because I need to know which things I need to handle on the OpenGL side, because everything else I can just call clear on my internal structures, and those will be fine. Okay, so the first thing we do is we poll for the max uniform buffer size and binding points, and this is just for the sake of having it. The uniform buffer binding points are used for ensuring that we never go overboard with the number of uniform buffers that we use in our shaders. So that's fine. It'll probably never change during runtime, because for that to change during runtime, you need to like update your driver or something while you're playing the game, and that's like, yeah. We have a local copy of the model view projection matrices. Then we utilize create uniform buffer in order to set up the per camera and the per draw uniform buffers. So a uniform buffer, just if you're uninitiated, a uniform buffer is a buffer of memory on the GPU that is accessible by all shaders. So if you're using a regular uniform, you can update the value from your code, and then that data will be available to your shader program on the next draw call. A uniform buffer is like that, except for it's a contiguous block of memory, like a struct. And that is available, you update it once, and it's available to every shader. It's shared between shaders, in other words. So I have two default ones. There's not. I don't prescribe a lot of structures in Enterprise. I do prescribe these because they're universal. There's stuff that you'll need to change every time you're changing your rendering point of view. So if you're moving a camera, if you're rendering from one camera, then you render from another camera. These are things that have to change, and that includes the model view and model view projection matrices. So those are things that have to change when you change the camera around. And then there is the per draw stuff, which is stuff that happens every frame, but only once per camera. So that is like if you're needing to access data that will update once a frame, we only update it once a frame, and we don't re-update it when you change your camera perspective. So I just need to make sure that these are deleted inside of cleanup, and they are. Delete uniform buffer, per draw global uniform buffer, and per camera global uniform buffer. However, I need to reset their values when you stop playback in the editor. So I'm going to need to add a call here. I'm going to go void graphics. It would be editor play cleanup frame buffers. Oh, hey, do we already have that? Do I already have editor play cleanup frame buffers in here? Maybe I put it in the header and forgot. Oh, frame buffers. Sorry, I need uniform buffers. Like that. Cool. And then this will be the cleanup call that we use for this section. So I'll put that here, static void editor play cleanup uniform buffers, like that. And then I need to add this to the parent editor play cleanup. So now we have a call that's going to be invoked whenever we go to stop editor play, where we can deal with the frame buffer stuff. So let's save and close those files and come back. So what I need to change in the case of these two uniform buffers, heading back to the list, uniform buffers created. I need to delete any frame buffers that were created during play in editor. I also need to reset the default uniform buffers. So in the case of the per draw uniform, or per draw global UB, I'm gonna say I think it's set uniform buffer data. Yeah, set uniform buffer data. We pass in the handle to the uniform buffer. So in this case, we'll just do the per draw global UV. And then we basically just pass in a pointer to the data that we want to pass in. So in the case of the per draw camera or per draw global UV, we just take the, I think it's going to be the bottommost element of the per draw stack. And then we run it. Wait, actually, now that I'm saying this out loud, I'm realizing that's actually not what I need to do. I actually don't care about those. The reason why is because the per draw and per camera global UVs, those are updated every frame anyways, so I don't actually need to reset them. What else do I have though? What state do I have? I actually don't have any state that runs on the graphics card, so I can just go through and delete stuff on my end and it'll be fine. That's cool. So let's go through the list. Bound uniform buffers created. So we're going to go to create uniform buffers, or create uniform buffer here. So this is the code that you would invoke in a custom renderer that creates a new uniform buffer. So this is a very, for example, you would for a specific game system that needs to pass data to your shaders, like a wind physics system or a wind simulation system, you would make a uniform buffer containing the state of the wind system, and then it would be available to your shaders that utilize it. So here we need to start tracking any uniform buffers created during play in editor. So that way, when you stop playing editor, we can flush them, get rid of them. So this is going to require a little bit more state. Let me see if I can organize the current state variables up here to make this a little bit easier. Uniform buffer size. So these are the OpenGL maxes. Uniform buffer sizes. Block names, binding points. Yeah, this is not very well organized. Block names, binding points. Uniform buffers are addressed by name. So the way that the API works is that you, in your shader code, you'll declare the uniform block with a name, and then you just make sure that your uniform buffer object in Enterprise is of the same name, and then they automatically pair up, they automatically connect, which is rather nice, but it means that I have to track for every block in a shader. I have to worry about where it binds up to. So that's what this is for, OGL. Uniform block binding points, we map the name of the block and the binding point. Yeah, I think that's... I'll come back and reorganize this later, but I'm gonna do a static std. I guess I'll do a vector of graphics uniform buffer handles. And this is gonna be all of the uniform buffers that we've created during play in editor. So I'll say uniform buffers created during editor play. We'll do a really wordy but clear name for starters. And then anytime we go to create a uniform buffer, down here, create uniform buffers, we will track the ones that occur during play in editor. So first thing is that we need to do an if-def EP build dynamic. And this condition is necessary because your shipping game code will not be DLL based. It will be an all-in-one executable statically linked to the Enterprise Engine library. So we only do this check if we are either in the launcher or in play mode in the editor. And then we have to check whether we're in play mode. So we do if runtime is why aren't you working for me? IntelliSense is run editor, but I'll just type it in. Runtime is editor and is running. For some reason, IntelliSense is telling me I can't use these. Incomplete type not allowed? Why not? What's incomplete about this? We're in the Enterprise namespace. We're inside of a graphics call. Oh, is the graphics system not friends with? Well, it's not giving me an error on access, actually. So maybe there's an ambiguity happening here. That's confusing. Let's take a look at the runtime header real quick. This is runtime.h. I'm trying to access is running and is editor, which are static members. They're private, but the graphics system is a friend of it, so there's no private members among friends. So this appears to be like a scoping thing. Do I? Oh, I'm just missing the header. Hang on. There we go. All right, that's all better now. Cool, so if we are creating a uniform buffer and we are in play in editor, we will do uniform buffers created during editor play dot pushback, and we'll push back the return value. And that's good. Cool. And then when we go to clean up down here inside of editor play cleanup for uniform buffers, we will need to go through that whole list. So we'll say for graphics. Actually, I don't need to use graphics inside of this call because it's part of graphics. For uniform buffer handle, UBN uniform buffers created during editor play. So we'll iterate through this whole list. We will invoke, I believe it's delete uniform buffer, yeah, on it. Cool. And then we will clear the list. Perfect. Now the other thing that we need to worry about is making a guard check against deleting too many of these. If you were to create a uniform buffer during play in editor, and then you... Wait, what am I saying? This is not a stack. In the case of the frame buffers are handled as a stack in Enterprise. So you push a frame buffer, and then you push a frame buffer on top of that, and whatever's the topmost frame buffer is what you're rendering to. In this case, though, when you go to create a uniform buffer, you are addressing it directly. You are not accessing a uniform buffer in the form of a stack. So you're actually never in danger of deleting a uniform buffer that you didn't create, because that would require that you have the handle, which I don't know, somebody might find a way to break, but it's very unlikely, so I'm not going to worry about it. Cool, so now we've got the uniform buffers being deleted after leaving play mode, anything that was created. And then when the project goes to unload here, we do actually just go through and delete the default uniform buffers. I should probably add a call to make sure that all of the individual ones are deleted as well. So let's go to the state code up here. When you go to create a uniform buffer, we track its size, its name, its binding points. Yeah, these things actually, just the names and sizes. And now that I'm saying it out loud, I'm realizing that this is actually a per shader thing. Uniform block binding points. Uniform blocks are the items that are inside of the shaders. So those things probably need to be cleared as well. Yeah. So, do we actually save the handle anywhere? I don't think we do, actually, now that I'm looking at it. Uniform, block names, buffer. Should you need shrink to fit for those STD vector after cleanup? Probably not. They should be empty after cleanup. If you do you mean? Oh, I see what you're saying. If I go back to cleaning up from exiting editor play, you could. I don't see the point. When you go to clear out, the memory is still allocated. I think it's realistic to expect that whatever amount of memory was used during one play in editor should stick around for the next play in editor. So if I was to go and use shrink to fit after we've cleared all of the uniform buffers created during play, we'd be talking about at least if I'm remembering what shrink to fit does. Let me double check. But shrink to fit, if I'm remembering correctly, actually takes and reduces the memory usage, by freeing unused memory. It is certainly possible that some buffoon writing a game might accidentally create like way too many uniform buffers and then wind up expanding the size of uniform buffers created during editor play, expanding that memory to, way too big. But the elements that are going in here, the uniform buffer handles themselves, are actually pretty small. They are only type defs for unsigned ints. So for that to be a huge factor, I just don't see it. So I think I'm fine with not doing shrink to fit on those and just like keeping that memory around so that the next time you go to play an editor, it reduces the likelihood that it'll have to reallocate. But yeah, that's a fair question. That was a good question. But I just don't think it's a concern that applies here for my use case. So we don't maintain a list specifically for the uniform buffers that we create. We do, however, maintain these two maps where every key is one of the uniform buffers that we've created. So we could iterate through one of those. I don't like that very much. I think it's inelegant, but that's probably what we're gonna do. So uniform buffer sizes and uniform block names. And then the uniform binding points, I believe that's... I'm trying to remember how I put all this together way back when. Create uniform buffer. So first thing we do is we check whether or not a shader has actually set up a block of the same name, because it's possible that you would load a shader before you create the uniform buffer that would link to it. So this is a communication over to the shader side, and if it equals 0, then we need to set up the binding point ourselves. Otherwise, we just use GL bind buffer base and bind over to the one that was defined when you compiled the shader, if that makes sense. So it's complicated under the hood stuff, but it's meant to make the API itself easier to use. Uniform block binding points. Yeah, so we're gonna skip on uniform block binding points, I think. I'll deal with uniform block binding points on the shader side, so on shaders.cpp. But for our purposes, we care about these two. Here. That. So we're going to need to loop through one of these at least. So we'll go for const auto, and then the key value pairs for, the key value pairs for uniform buffer sizes is going to be the name of the uniform buffer. The frame buffer handle. Really? The frame buffer handle? Why is it saying frame buffer handle? Uniform buffer handle. I think IntelliSense sometimes gets confused between these type defs. This is the type def for frame buffer handle and uniform buffer handle. They're both type defs for an unsigned int. And so sometimes it swaps in the wrong name here, but this is supposed to be a uniform buffer handle key, and then the size is the other. So I'm going to say UB and underscore. I'm not using the size in this case. So the UB should be a reference to the uniform, to every uniform buffer handle that we have created. And then we'll do, for each of those, we'll need to do a deletion. So that'll be just making sure I'm not overlooking something here. I think it's essentially GL delete buffer. Though there might be consequences to having GL bind buffer base. Like do I need to unbind as well? I'm not sure. That doesn't seem to be a thing. So really we would just be using GL delete buffers. And we would pass in a list of all the buffers we want to delete. Yeah, that makes sense. Okay. Yeah, I think that's everything. All right, so back in the cleanup code, for every uniform buffer that we have created, we are going to call epgl to wrap the GL code, and we'll call GL delete buffers. And we're going to need to call it eventually on that buffer, so it would be like 1 and then the address, or then it would be UB or something, or the address of UB. But we can do a little bit better, just like we did in the other system with the frame buffers. We can actually make an std vector of the uniform buffers that we want to delete, and then submit a single call to OpenGL to delete all of them. So this will be a GL uint, I believe. This will be UBOs to delete. And so for every uniform buffer that we've created, we will push back the handle. UBOs to delete dot pushback UB. And as it happens, I happen to be using the actual uniform buffer name as my uniform buffer handles. So I don't actually have to translate in this situation, but when I go to implement like Vulkan or DirectX or something later on, I will need to implement an intermediate step for translating from the raw API handle to my generic handle. But in this case, they happen to be identical. And I'm just double checking that that's actually the case. Buffer 0. Yes, we get it from glgen buffers, so we can just pass that into the UBOs to delete. Cool. So we've gone through all of the uniform buffer handles, and now that we've got them all in a nice contiguous array, we can do EPGL for error handling. Then we can call GL delete buffers. We pass in the numbers, that'd be ubos to delete dot size with an E. And then we pass in ubos to delete dot data to get us the pointer to the contiguous memory. And I need one more parenthesis to close that off. Cool, so this will delete all of the uniform buffers in memory at once. And because this is going to be called when we go to close the project, when we close the project, it destroys the engine runtime, which clears all of these out at the same time. It flushes like everything, and it gets reconstructed again. I don't actually have to care about any uniform buffers that the editor might be using, because it's going to reconstruct those. Cool. So that's that. Now for the other state that we need to worry about, we need to actually delete on uniform buffer sizes and uniform block names. Here we go. What have I been doing before the game engine, Embedded Systems Mobile? I am not a professional programmer. So that's that question actually doesn't really apply to me. I've been a self-taught programmer. This is probably my first large-scale project. I've done a couple of personal things, but I don't actually work as a programmer, so I can't really claim that I've worked on embedded systems or anything else really before this. I just kind of picked it up and started doing it. Though I've been a hobbyist programmer for it would be over 10 years now, since the first time little baby Michael started to program. But it was always a hobby and not a job. So I don't know, I might transition to doing programming work, but for now this is, I don't really have a lot of projects under my belt. But yeah, anyway. So we needed to clear the actual state that we track per uniform buffer. Then we delete the global uniform buffers, and then we pop the per camera UB data stack. So this is when you go to render through a camera, you're actually pushing a camera on top of a camera stack. The reason why I did it this way is because if you're making a renderer for a game that features like in-world cameras or portals or something like that, then what you might want to do is you're rendering a scene, you've pushed the camera for the perspective that you want to render the scene from, and then you have a system say, okay, based on that perspective, I'm going to make another camera and then render the scene again through that to a render buffer or to a frame buffer. And then that will be available for use in the first draw call. And in order for that to work, you have to remember both camera states. So I actually implemented it as a stack, and we go and pop all of them from here. And I don't think I need to do anything else from here. I think that covers our bases. Uniform buffer sizes, names. The binding points is going to be cleared up on shaders.cpp. We are clearing up the uniform buffers created during editor play. When we end editor play, this is being popped correctly. Per camera, global UB, and the global stuff is being reset. Yeah, so that's everything for this. So I think we're good for now on uniform buffers. I'm just going to make sure that when I go to rebuild and do stuff, I'm not gonna that I didn't just break something. And lo and behold, I did break something. What did I break? Out-of-line definition of editor play cleanup uniform buffers does not match any declaration in Enterprise. Oh, I guess I must not have added this. Let's go to graphics.h. Oh no, I did. That's it. Doesn't take any parameters, it's void. Graphics, no parameters. What did I mess up? Out of line definition does not match any declaration. Graphics, editor play cleanup, uniform buffers. Oh, I forgot to conditionalize this. So when it comes to editor stuff, the editor loads your game project as a DLL, and it is only, what's this? EV build dynamic. What are you? Oh, that's the error from before. Okay. You have to conditionalize the compilation of stuff that's only for the DLL version of your game. When you're working on the standalone shipping game, this is not used anywhere, so I just strip it out using the preprocessor. Yeah, defining my skill level in C++ is a little hard. It's disingenuous to say that I'm an amateur, but it's also disingenuous to say I'm a professional. I've never worked as a programmer. But I can tell you, I can talk about, stack frames and vtables and things like that intelligently. Is it just me, or is the music a little loud? Yeah, it's a little bit better. Come on, I'm waiting for the compilation to finish. And whenever I change the lowest level headers, it causes a whole bunch of compilation units to stop and have to rebuild. Perfect. I think that's cool. Yeah, it's it's nice to be self-taught, and it's kind of nice to, be working for yourself, but this engine's not paying the bills or anything like that. It's just a personal project. And an open source one, so it's not likely to make me any money. So when we go to close project, let's see what happens. Delete uniform buffer. Okay, so this is a call from clean up uniform buffers. Okay, what are we doing here? Oh, okay, hang on. So I made a mistake here. I just added all this code to automatically delete every uniform buffer that's been created. That automatically includes the uniform buffers for the per camera and per draw global stuff. So I don't actually need these calls anymore. I can just get rid of that. Let's try that again. I didn't modify a header, so this should be just a couple of compilation units or translation units to compile. Yeah, only 8 of them. Let's try that again. We've got play and stop. Works fine. Oh, I was testing close project. That's what I was doing. Cool. And we've got another error. This is the one that I've been deliberately skipping over in shaders.cpp. I'll come back to that after this. And then this is another warning of the same vein. But other than the stuff in shaders, the warnings that we encountered, everything seems to close fine. There was another problem though with opening projects, I think. Oh no, that worked fine as well. Okay, it was opening and then play, and we go to see what that error is. And it's also a problem with shaders. So we'll have to address the shader cleanup soon, but not quite yet. But yeah, I think that's everything for the uniform buffer cleanup. So looking at this list, we are here. Okay, we are now down to shaders, textures, and vertex arrays for cleanup. Yeah. So I think that's going to be pretty smooth sailing for the vertex arrays. The shader stuff I started and stopped because it is the most complicated part of my cleanup process. Because if you take a look at all of this code, this file contains an entire GLSL preprocessor, which is naturally complicated because it's having to read through and understand another language and augment it with my own directives. So this is going to be a tricky next step. I've got to go to the bathroom. I'll be back in like, I don't know, a couple minutes. Yeah. Alrighty, I'm back. Alright. Now, concerning the next thing to do, I think I'm going to start with vertex arrays instead of going on to do shader stuff. Because it is the most complicated thing, I am going to save it for last. Because I'm not even sure if I want to do this part on stream. I may need to spend a while and focus on it. But vertex array stuff, I think it's in its own file. yeah, vertexarrays.cpp. Vertex arrays are basically a wrapper around creating a vertex and an index array. So in OpenGL terms, there's a thing called a VBO, a vertex buffer object, or sorry, VBA, vertex buffer array, and it is the combination essentially of your vertices and your indices. So thinking in terms of like if you think of like a cube, you have 8 points, the 8 corners of the cube, and you've got 2 triangles per side. If you were just to supply a list of triangles, then you would have every point defined multiple times. Actually, it would be there's 3 adjacent sides to every point on a cube, 2 triangles per, so that would be what, 6 times you'd have to duplicate the data for a vertex, for every vertex. I don't know, my math might be off, but the idea is that usually you'll supply the vertices one by one, and then when you specify the triangles, you just tell OpenGL, okay, I want this vertex, and this vertex, put a triangle in there. I do something similar, except I don't literally use vertex array objects. I don't tell OpenGL to swap those in and out. I forget the exact reasons why I did that. I had thought long and hard about it and chose to do it this way. But in my case, I need to, when you go to create a vertex array object, you are actually creating just the vertex buffer and the index buffer, and I need to handle what happens to those. So my policy for vertex arrays is that if you create them during editor play, then we track the ones that you create that way, and then we delete just those when we finish editor play. In most cases, you're going to be loading those from the project level instead. So that is, you'll have a game system that adds a mesh component or something to your entities, and the system is what loads the vertex array objects instead of the game code, and then the game code just operates on them, the entities that you load into your scene using the editor. So for play in editor, we're probably not going to have to worry about this too much, but I want the ability to instantiate and create anything you need inside of a game state. So I will add a guard for vertex array objects created during play in editor. So we'll need to add a special cleanup call. So we'll do void graphics editor play cleanup underscore vertex arrays, and then we'll need to add this to the header. So we'll go to graphics.h, boom, add it down here as a static void function with no parameters. Save and close that, and then I need to wrap this in ifdef EP build dynamic. Oops. There we go. And if, all right, and then in here we will delete any vertex arrays that we had created during play in editor. And just like before, that means that we're going to need to start tracking any vertex arrays that we create during play in editor. This is actually going to be fairly straightforward because we can simply just call delete vertex array on each vertex array handle that we've created. So when we go to create vertex arrays, right up here, before we go to return the array that we're dealing with, though that's an interesting name, return bound array. Do I have more than one return statement in this block? No, it doesn't look like it. So right before we return the array, we are going to store it in a structure. I think that's going to be a vector. So what we'll do is we'll say array vertex arrays created in editor play dot pushback. And I haven't created this vector quite yet, so it's gonna IntelliSense is gonna yell at me. But basically we just store it, and then later on we can use it. So let's go ahead and add it. I'll add it down here. We'll say if def ep build dynamic. We'll have a static vector of graphics vertex array handles. Vertex arrays created in editor play. Okay, and I need to say std on that. Cool. And then, now that we've got a list of all the ones that we created, we'll need to handle the deletion of them when plain editor is finished. That would be at the very, very, very bottom down here. So we'll say for every const vertex array handle reference in vertex arrays created during editor play, we basically just call delete delete vertex array on it. However, vertex array, delete vertex array is going to have to handle modifications to the vertex arrays created during editor playlist anyway, because if the game code deletes its own vertex array handle correctly during editor play, we don't want to try to delete it again. So I'm going to need to change a few things about this. I'm going to say, first I'm going to make a copy of this vector. Say std vector of vertex array handles. Array handles. I will say vertex arrays to delete. And we'll set that equal to vertex arrays created in editor play. And then we can iterate through it instead of iterating through the original. And then at the very end, we can say vertex arrays created in editor play dot clear, like that. Cool. So we've got a list where every time we go to create, oh, hang on, I skipped a step here. Instead of, yeah, I forgot to conditionalize this. So if we are in the editor, so we'll do if def ep build dynamic. If I can spell today. So I say if def, and then we'll say if runtime is running and runtime is editor, then we will do this, because we're only going to do this when we are in play mode. Except for I need to include the runtime header, so let's do that. Include enterprise/runtime.h. Yeah, cool. And that squigglies should disappear soon. Come on, there you go. Cool. So if we're in editor play and we create a vertex array, we push back its handle to this list, and then we iterate through them and call delete vertex array on them at the end. Now, the last detail is that if we go to delete the vertex array manually from the game code, we also need to remove it from that list. Otherwise, we'll be deleting a thing twice when we go to end play editor, play in editor. So we've got, I guess what we need to do is we would need to search through the vector and delete them. I think this is why I used sets on the other examples. So let me change this from being a vector to a set, because there's a bit of random access that's going to happen during gameplay. So we'll say vertex arrays. Instead of dot pushback, we'll say dot insert. And then down in the cleanup code, instead of setting this equal to the other, we're actually going to have to iterate through it. Yeah, so what we'll do then is we'll just make this a duplicate of that set, iterate through the set, and then call it delete on that. All right, cool. Ooh, all right, back to the delete code down here. So basically, we just need to confirm whether the vertex array that we're deleting is part of that list, and if it is, get rid of it. So we'll do, this is another conditional section. So we'll do if def ep build dynamic and if ep build dynamic, and then we'll do if I just had a thought that might be important. What if the developer tried to delete a vertex array that was not created in Plan Editor? Should I have a guard against that? I suppose I should, but I'm not going to worry about that for now. Because in order to delete a vertex array handle that wasn't created during Plan Editor, they would have to have the handle to begin with, and that would mean that they would have to get it from a system that created it. So I'll deal with that later, but I'll make myself a little note. Maybe I'll address this before I go to commit my code. I'll say to do implement guard against deleting systems VAHs, and then I'll worry about that later. But for now, what we're worried about is if we're in the editor, so runtime, if runtime is editor and runtime is running, like that. If we're in the editor, we need to check whether or not the vertex array that we're deleting is inside the list, and remove it. But actually, it would be a little bit better if we just called, I think it's just erase. So vertex arrays created in editor play dot erase, and then we can pass in the handle that we want to remove, which is the one we were passed, which is just called array. That's the name of the parameter. But you know what? Now that I'm thinking about it, we actually don't care whether we're in Plan Editor, because if you call erase on a set, and I'm gonna double check this real quick on CPP reference. If you call erase on a set, I don't believe it's an error condition if the element doesn't actually exist in the set. Removes the element if one exists with the key equivalent to key. Cool, and I guess that's fine. So we can actually just, whether or not we're in Plan Editor, we'll just call erase on this set. And if it was there, then it's gone, and that's all we need. Okay, I think that's it. That's all we need. So that's the Plan Editor stuff handled, where we delete all new vertex arrays when Plan Editor finishes. However, now we need to talk about deleting everything created by the project. So let's go to that. We specifically care about the VBO handles, so the handles to the OpenGL stuff, because we're going to be dumping all of this memory anyway. But the vertex array objects that's inside of the graphics card API stuff, that's going to persist after you unload your project, because the OpenGL context is going to remain in the editor. So we need to clean that up. STD map, graphics, vertex array handle, GL uint. So we care about VBO handles. We care about number of vertices and vertex strides. I think actually we care about all of this. Okay, I'm just going to copy all of the state, paste it down inside of the clean up vertex arrays call, and then just go through every element and make sure that it's reset correctly. So that is not actually a piece of state, that's a constant. Here we go. Then the vertex array handle assignment stuff starts here, so yeah, we'll set it back to its default of 1. The currently bound array will set to be that's eventually going to be 0, but I'm going to move this code to the bottom of the code block because I don't actually I may need to know which array is currently bound before the end of the cleanup call. Okay, so the VBO handles, we actually need to go through all of those and call delete on the OpenGL side. So let's do that now. We'll do a range-based for loop. We'll do for, and this would be, we have a key that's the vertex array handle on the enterprise side, and then we have the value that's the handle on the OpenGL side. So this is going to be a good place to use C++ 17's structured bindings. So say const auto reference, and the key we're not going to use at all, and the value is going to be the OGL handle for the array, or for the vertex buffer. Cool. So for every vertex buffer, we just call delete buffers basically. At least I'm pretty sure it's delete buffers because we use it's delete buffers. Here we go. So we're going to do EP. Well, actually, let's assemble a list of all of the handles and then delete them all at once, like we had in the other cleanup calls. So I'm going to say std vector of gl uint, which is the type of the OpenGL handle, and we'll say VBOs to delete. And then for every OGL handle in VBO handles, we'll call VBOs to delete dot pushback OGL handle, like so. And at the very end of this iteration, we can then call in OpenGL we'll call GL delete buffer, and we pass in the number, which is going to be the size of VBOs to delete, and then the data, which is going to be VBOs to delete dot data. Boom. Okay, so that's all of the vertex buffer objects deleted. And then in here, number of vertices, vertex strides, attribute names, offsets, base types, blah, 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 blah. All of these things I believe I can just call clear on. So let me do that. And these are all the structures that Enterprise uses to track data for the purpose of manipulating the OpenGL side. So this stuff we can just dump. Cool. Then we have the vertex arrays created in editor play. That's handled outside in the editor play cleanup vertex arrays method. And now we have the IBOs, which are the index buffer objects. So like I was talking about before, you have the buffer of all the points of your mesh. And then for every triangle, you specify the index into that buffer that represents the point of the triangle you're trying to represent. So this winds up being way smaller. So in the case of the IBO handles, we actually have to go through a similar loop to what we did above. I'm going to just copy the loop above and paste it and then deal with it there. So essentially, we got IBOs to delete instead of VBOs. I'll go ahead and call OGL handle. I'll continue to use OGL handle as the name of the handle iterator. And then we push back into IBOs to delete, dot push back the OGL handle. And then we call, you guessed it, GL delete buffers on IBOs to delete, using dot size and dot data to get the parameters for GL delete buffers. Awesome. And then the last thing is to actually take and call clear on IBO handles. Boop, like that. All right, and then IBO num of indices. Yeah, we can just call clear on that as well. Boom. All right, we're on a roll. Then there's the global VAO handle. This is an interesting one. In order to have an IBO and a VBO, in order to have those, you need to have an OpenGL side vertex array object. And I mentioned earlier that I don't actually use those. Instead, I just make a single one, and then I continue to use it, and I just rebind the VBOs and IBOs directly. And I can't remember the reasoning why I did that, but I believe it was deliberate when I made that decision. So we do keep a reference around for the global VAO. And I'm trying to decide right now whether we need to delete it. So let's take a look at the init call. Init vertex arrays is invoked when we start up the engine, or when we load a game project, when the engine runtime is created. There's a little testing here to make sure that we are not on a platform that somehow exceeds our expectations of how many vertex arrays we need to support. And then we generate and bind the global VAO. So I guess every time we load the engine runtime, we generate and bind the global VAO. So naturally, that means we're going to need to unbind and delete it. So let's do that down here. So this is going to be an enterprise GL call. So we do epgl, and then we do GL code in here. We would say a GL bind buffer, and then we would say, actually no, we would say GL bind vertex array, and then we would pass in a value of 0, I believe. And when you pass in a value of 0 to GL bind vertex array, I'm at least 90% sure that unbinds. Here we go. 0 to break the existing vertex array object binding. Perfect. Cool. So we've unbound the global vertex array, and now we can call epgl GL. I believe it's okay. So it is a delete vertex arrays call. like that. And delete vertex arrays, I'm assuming, takes a buffer, a count and an array pointer. And in this case, we only have the one, so instead of doing this whole thing with constructing a vector with all of the handles to delete, we simply say there's only one, and we pass in the address of the global VAO. And the global VAO is not itself an array, but we just pass in the address of it and say only use, it's a size 1 array, essentially, and then we should be good. Cool, and I think that's all we need. I can now move the vertex array tracking stuff back up to the top, because it turned out we didn't need to know what the bound array was while setting this up. Actually, one of these calls we might need to know. No, we don't. We're doing everything directly from here. We're doing GL delete on all the stuff. So I think that's it. I think that's all the vertex array objects cleaned up at the end. Unfortunately, the situation is that I probably am not going to need to, I'm probably not going to want to spend time constructing tests for every single one of these scenarios. I'm just going to need to move on and then fix bugs as I come across them. It's kind of hard to do test-driven development in game engines sometimes, because you're talking about a platform upon which you can make so many things. And this is a situation where I think it's probably better just to code the thing, use it, and then fix the bugs that you come across as you're using it. That might be a politically charged opinion among programmers, but seems to be compiling smoothly, but it's going to be a minute because vertex arrays are used everywhere. Actually, it's compiling 62 units because we changed the graphics.h header, which is used everywhere. We're also building for 6 build targets at once, so okay, there we go. Yeah, build finished with Xcode 0. Seems like we're on the right track. If I go to, excuse me, if I go to close the project, we have the same error that we've been glossing over from shaders, .cpp, but other than that, it seems to unload properly without any errors. And I'm out of curiosity, I'm going to open up the project again, and then hit play, and then go through this stack. Let's make sure that, okay, so the point of failure is still in shaders. All right, let's review the list. So we have now taken care of the vertex arrays. Now we are down to cleaning up after the shaders and the textures. And again, I'm gonna punt the shaders down the road a little bit because that's gonna be very complicated and boring to figure out. Let's take care of the shader cleanup, or sorry, the texture cleanup now. So we can close out of all these. We'll go to textures.cpp. Bam. And this is a fairly sizable file. It's about 1,000 lines. But the logic is pretty straightforward. It's just a bunch of branching that makes it look like it's a lot of stuff. But yeah, what we need to do here is when we are leaving Play in Editor, we need to delete any textures that were loaded during Play in Editor. And then we need to delete all textures outright when we go to close the project. So let's add a void graphics cleanup. sorry, editor play cleanup for textures, like that. And then let's add this to graphics.h down here. Wait, that's the wrong spot. This is the right spot. Like that. Editor play cleanup, blah, 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 blah. All right. And then here, I'm just gonna go ahead and compile at this point, so that way I don't have to worry about a whole bunch of translation units changing when I'm ready to work. So I'll let that run in the background. Oh, thanks for the follow, Alex. It seems like this might be the best time of the week to stream. I'm getting a bunch of follows this stream. But yeah, editor play cleanup textures. We need to track all of the textures that we load during play in editor. So I'm going to need to add some state for that. How's everyone doing? It's looks like we got a little bit of a crowd today. I'm adding a set, an STD set of texture handles called texture handles loaded during editor play. And this is going to be the way that we track the textures that we have loaded during editor play, as the title suggests. I probably didn't need to explain that. I'm going to move this up, though, below here, the loaded texture stuff. And then whenever we go to create a texture, we will add the handle to the set. And when we go to delete the texture, we will delete it from that set. Let's go down to the editor play cleanup textures call. What's this? Out of line definition? Oh, hang on. I apparently screwed up something. Graphics.h static void. Oh, yeah, I did it again. I need to conditionalize this ev build dynamic, so that way it's not present in the static library version of the engine library. There we go. And then we need to do, well, let me recompile and clear that error out, because it's going to be annoying. Okay, while that's going, we need to do a loop through this set and then call delete textures on it. So what we'll do is what we did on the other systems. We'll do an std set of handles here. So this would be a texture handle, textures to delete, and we'll set that equal to textures loaded during editor play. And this will allow us to iterate through this set of textures without and delete from this set of textures without worrying about invalidating our iteration. And then we'll do for const texture handle reference textures to, or sorry, text, I'll just say, for every texture in textures to delete, we will call delete textures. Thank you, IntelliSense. Delete texture on text. And then we can call textures loaded during editor play .clear, like that. Cool. And in the background, it looks like our compilation finished, so that's good. Right. So during editor play cleanup, we are now clearing out any textures that were loaded. We just need to start tracking them. So let's go to create texture or load texture. And there's actually a number of load methods here. The one that's used most often is graphics load texture. You basically just specify the path, the filter and bitmap mode that you want, and it will load up a 2D image. However, you can also do cube map textures, or you will be able to. I haven't implemented these yet. I should say OpenGL supports cube map textures, texture arrays, and so on and so forth. So I've got all of these methods as well. Thankfully with an asterisk. Thankfully, I don't have to implement all of these right now. But I'll have to remember to do that later. So it looks like there's going to be two places I need to implement the tracking. The first is the simple graphics load texture, and then the second is graphics load font file. Because load font file, if we find it, here, load font file also generates a texture. Basically, you pass in a true type font. We run it through MSDF Atlas Gen, and it will create a texture with all of the font atlas stuff, with all the characters in the set. And if we don't use create texture in here, sorry, load texture. If we don't use load texture in here, which I don't think we do, we don't, then that means that we also have to track the texture from this call. All right, so graphics, load font file. We go through a whole bunch of stuff to make those font things work, because we have to track things like font metrics, like the advance, the width and the height of each of the characters, their UV coordinates on the atlas, and all that business. At the very end of all of it, we return text handle out, and then before we return text handle out, we need to push in textures loaded during editor play dot insert text handle out, like that. And now we are tracking any of the font textures that we create during editor play. Oh, but there's more to it than that. I have to do ifdef ep build dynamic. I wonder if there's a macro I can set up in VS Code. I'm having to do this a lot, where I do ifdef and then I have to duplicate and then set up the endif. Maybe there's a snippet that I could set up for that, but I'll deal with it later. So we've got ifdef ep build dynamic, and then we check if runtime is editor and runtime is running. And then if both of those things are true, that means we're in plain editor and we want to track the creation of this texture. Cool. And I will copy that out and head back up to create texture, or sorry, load texture up here. And this is where we return the texture handle. I don't think there's another place where we return a texture handle higher up. Nope. So we can, right before we return texture, we'll say, oh, hang on. Yeah, there, I used reference counting here. I forgot about that. So when you load a texture, we don't just load the texture and provide a handle. We actually do track whether it's been loaded before. which is a good practice for this situation. The idea is that if you have multiple places of code that use the same texture, then we don't duplicate that memory on the graphics card. We just count how many places use it, and then we increment the reference count. So I actually need to be careful that I'm only tracking the reference count increases. That actually makes this whole situation a little bit more complicated, because multiple places in your game code might call load texture, and they would just increase the reference count once. And every time I call delete texture, it actually will decrement the reference count and only unload when it hits 0. So here's that code: texture reference count if texture reference count path of texture handle texture equals 0. So if we hit 0, actually that should probably be less than or equal to 0, just to be safe. Then we go and delete the texture data. So actually what we need to be tracking is not just which textures have been loaded during editor play, but how many times. That's fun. So I'm going to need to change around how this code works a little bit. We've been using an STD set just to track the handles themselves. I need to track the handle and the quantity of loads. So we're going to need to make this a tuple. So I'll make an STD pair of texture handles. Actually, that's not going to work either. I'm going to need to change this whole thing to an STD map. So this will be a map where the key is the texture handle, and the value is the number of times it's been bound, so just a regular integer. And I'm going to rename this a little bit. It's going to be, instead of textures loaded during editor play, it's going to be texture loads during editor play. That'll be a little clearer. So this is tracking how many loads per texture. Cool. And now we're going to need to do a little bit of changing. And instead of saying .insert text handle out for the font file creation code, we're going to create the element by using the square braces. So when you do square brackets and you provide the key, that inserts the element, and then we just need to assign that element the value. Got guys drilling on my roof, and they periodically come to the side and make noise. Anyway, we just increment it from here. Texture loads during editor play. If the key didn't already exist, we insert it, and then we increment the count, which starts at 0, because that's the default value, is 0. Cool. And then we'll do something similar for the destroy calls. Down here at the bottom, when we go through the textures to delete, we are no longer dealing with a set. We are dealing with counts. So I'm gonna actually get rid of this first line. We're not going to duplicate texture loads during editor play. We're just going to iterate through it. And then we are going to clear it at the end. And what we'll do here is we'll say const auto reference, and we'll do a C++ 17 structure bindings to get the frame buffer handle and the quantity. And then we will do a nested for loop that calls a delete on it for once for every load. So we'll say FB is the key and load count is the value. And we'll say for int I equals 0, I is less than load count, I plus plus. we will call delete texture for the, I said FB, but we're not dealing with frame buffers anymore. We're dealing with textures. So text. We will call delete on text. And then we can clear the list. So my plan is that inside of the delete call now, when we go to delete the texture, let me find that. Delete texture. Instead of emptying out, instead of destroying that key, I will only decrement that key. And then we will clear out those keys when editor play is finished. I guess what I'll do is I will do it right after the regular decrement. Or right before. So we'll say if def EP build. Is there really not a snippet? I guess there's not. I'll have to set one up at some point. EP build dynamic. If runtime is editor and runtime is running, texture loads during editor play at texture --. And then if we hit 0, then we'll that's when the unload happens. If we hit less than 0, I should actually do a warning here, because that would indicate that you have attempted to delete a texture more times than you've loaded it, which I don't, that might be a hard situation to accomplish. It might be hard to do that, to make that big of a mistake, but I'm gonna catch the developer if they ever do that. So we'll say if texture loads during editor play texture is less than 0, then we will issue a warning. Attempted to delete texture that wasn't loaded during editor play. And what information can I provide about that failure? I could probably provide the path to the file. So I have a map, it looks like, that's an STD map of path of texture handle, so I can pass in the handle and it'll give me the hash of the path. So I can do path of texture handle, and I'll provide in texture loads during editor play texture. Actually, I would just pass in texture. Texture. And then this returns a hash name, so I have to unhash it for the purpose of the message. So I'll say hash name to string, passing in that hash name. Okay, it's a little bit wordy. Attempted to delete texture that wasn't loaded during editor play texture, and we get the path of the texture. Yeah, all right, that's good. Perfect. I think the only thing left is I haven't added the load increment to the regular load texture call. So underneath load textures, go to the very end, and right where we would increment the reference count for the texture, we will also increment the reference count for texture loads during editor play. So if the texture was loaded by a system and then again gets loaded during play in editor, we are only counting the loads from play in editor here. Cool. And where does that leave us? That leaves us with the regular cleanup. So cleaning up the state when you go to unload the project. And just because this strategy has been working so well before, I'm just gonna copy every piece of state from up above. And, oh, hang on, I forgot to do an ifdef here. Because texture loads during editor play is only used on the dynamic build, so I can take that out. Yeah, I'll copy out this entire block of state and then just go through every single one of those and make sure it gets all deleted. Okay. So there's max texture slots. I don't need to reset that. Max texture slots just tracks when you go to initialize your game. It'll query from your graphics driver how many textures we can bind simultaneously, and that gets stored there. Last bound texture slot, that matters. We do need to reset that. So what we'll do is we will just invoke OGL last bound texture slot equals 0. OGL texture in slot, that's at a dynamically allocated array. So that's actually handled already up here with delete OGL texture in slot. And textures uses draw is similar. It's a dynamically allocated array. So we just call it delete on it. Next, we have a map of the current slot of a texture. So we can tell whether a texture is in a texture slot, so we don't have to rebind it. And if it is in a texture slot, which slot it is. So this map needs to be cleared. Like that. And now we're on current sampler assignment. Now this uses a type def called shader variant map. It's essentially just a map of the hash name of the shader to a map of the hash name of the shader to a map of a set of hash names representing all of the shader options we have turned on. And that returns returns some type. In this case, it's going to be the sampler assignment, which is a map between the sampler name and the sampler object directly. Man, this is some tricky stuff. Here we go. So, how do I use this? It looks like this is referring to the texture slots. So you pass in the shader, you pass in the options, and then you pass in the name of the sampler in that shader permutation, and you could have several. And so for every shader variant's samplers, we have the integer that represents the texture slot. Okay, that makes sense. Just just trying to follow how this all works is sometimes hard for me, even though it's code that I wrote. So what we need to do here is, actually all we need to do is clear it. I don't need to go in and tell OpenGL to unbind these. I just need to set clear. And then in OpenGL land, if we go to unload a project, it'll still have those textures loaded, but they'll be replaced by textures in the next project, is the idea. Well, sort of. I'm on the fence about that. I'll make myself a note and come back to this if this is important to do. To do review if texture slots need to be unassigned. Cool. Now looking at the loaded texture stuff, we have texture references, texture handles by path, and then the handles themselves. So these are, you pass in the hash of the file that you loaded. So in the case of MSDF texture handles, you pass in the path to the font file that you loaded, and then it returns you out the texture handle associated with it. We will need to go through and delete all of these. But I don't think we'll do it from these objects. Which objects would we do them on? This is all font metric stuff. Actually, no, this is where we would do it. So what we would do is we would take the texture reference count. We would just clear that because we no longer care how many times a thing's been loaded. We're unloading it, and that's final. And then these associate the texture handles by file path. So there's going to be one texture handle each element in these that I need to take care of. The path of the texture handle, basically you pass in the texture handle and get out the path to the file that loaded it. Is this a superset of the other two maps? It might be. I'm not clear. MSDF texture handles. Yeah, so every time we assign a value to texture handles by path or MSDF texture handles, we also pass in path of texture handle where the key is the path and the value is the handle. Oh, sorry, the key is the handle, the output is the path. So I guess what we'll do is we'll iterate through it and then use all of its keys for the deletion calls. That makes the most sense to me. But let's quickly confirm that it's not used in delete. EP assert. Or that it's not modified during delete, I should say. It is. So during delete, we actually invoke path of texture handle dot erase on it. So that means that I'm going to need to duplicate this structure in our cleanup code. All right. Took a little bit of thinking, but I think I figured it out. So we need to get every key out of path of texture handle. So we'll do for range space for loop. So we'll say no, you know what? I need to make a copy first. So we'll say texture handles to delete. And we'll make this a it was a texture handle hash name map. Like this. Texture handles to delete. That's not a fully accurate name because I've got a map of texture handles to hash names. I'm just not going to use the hash names in the for loop. So what we'll do is we'll say for, and this is where the range-based for loop will come in. We'll say for const auto ref, and we'll say text and underscore because I'm not using the path in texture handles to delete. Like that. Cool. All right, now I've got a loop going through every single texture that's been loaded. And now we can call delete texture. And pass in text. Though now that I'm looking at this, I'm realizing I need to put the texture reference count clear call. I need to move that below the loop because texture reference count's going to be decremented by delete texture. Actually, there's a whole bunch of stuff that's going to happen inside of delete texture that I don't care about. So actually, this is not the way I want to do it. I do need to get the texture handle, but it's more important for me to get the OGL handle. I think that the handle is actually the thing that's generated by OpenGL. It is. So as it happens, my texture handles are equal to the texture handle generated by GLGen textures. So I can actually just take and pass this key in directly to OpenGL calls. So for that, we're going to need to use epgl gl delete textures. And now, just like in the other cleanup calls, we're going to want to construct an array that we pass to GL delete textures. So let's do that here. We'll do std vector of texture handle. We'll call this texture handles to delete, and then we will iterate through path of texture handle and get the textures that way, and then we will say texture handles to delete dot pushback text. Cool. And now we can call GL delete textures with the size of texture handles to delete dot size, and then texture handles to delete dot data will get us the pointer to the block of handles. Cool. Good. All right. So that's every texture deleted on the OpenGL side. That's perfect. And now we can just take and clear these maps. Yeah. Same thing goes for path of texture handle. Texture loads during editor play. That gets cleared every time we end editor play, so that doesn't have to happen here. Okay. And now the last thing is font metrics. And font metrics are only used by enterprise, so we can actually just call clear on every single one of these. So that's great. Bam, bam, bam. Okay. All right, I think that's all we need. Okay, I think that's everything. I suppose we should unbind all textures from every texture slot as well. That's something that I kind of skipped over. Okay. Basically, we need to call GL active texture for every texture slot, and then call GL bind textures 0. So I'm going to do that up here before we do any of the state deletion stuff. We'll call OGL. Oh, sorry. This will be unbind all textures. So we'll call for int I equals 0, I is less than max texture slots, I plus plus. We'll call EP GL, GL active texture, GL texture 0 plus I. There we go. And basically GL texture 0 and all of the other texture units that you might have, and there's up to 32 in my implementation, I guess. All of these could be defined differently per platform, but it turns out that this is actually, these are always going to be offset by 1. So even though GL texture 0 might be different somewhere else, I think. Oh no, wait, that's wrong. This is the same for every platform. So basically texture 0 through texture 31, they're all offset by 1. So instead of doing like a switch statement or something, we just do GL texture 0 plus I to get the texture unit that we're dealing with. Then we will unbind. So we'll call GL bind texture, and I believe we just pass in a 0. Is that enough? Let me double check. Oh, we have to actually specify the target as well. So, oh, okay. Yeah, I need to actually specify what kind of a texture it is. So at the moment, all textures are going to be GL Texture 2D, but in the future that might not be the case. So this would work for what the stuff I'm using, but it's not future-proof. I actually do need to check. I need to check what kind of texture was bound there. I wonder if I have any state that covers that. I think I've just about hit my limit for how much I can do on live stream today. So I do have a state in the OpenGL side, sampler type needed for texture. And that'll give me back the type of the texture. And how I used it up here when we actually went to bind textures before is I did a switch statement that converted from the sampler type to the texture type that it needs. I'm gonna have to do the same thing down below. Kind of sucks, but it's not a one-to-one correlation, so you have to map it yourself. I'll copy all that. There we go. Like so. Okay, so first thing we do is we bind. We switch to every texture slot. So for every texture slot available on this machine, we will make it active, and then we need to identify the sampler type needed for texture, and the texture is going to be texture in slots, I believe. Is what. There's an array that I don't remember what it's called. Oh, it's in the OGL namespace. OGL texture in slot. Okay. So when we're looking up the sampler type needed, we're passing in OGL texture in slot I. And that will tell us which texture is in that slot, if there's any. So there's a chance that there's going to be no texture in the slot, so I'm going to need to have an early out up here. So we'll say if OGL texture in slot I equals -1, which indicates there's no texture in the slot, then I will say continue, which will move on to the next texture slot. Perfect. And then in here, we get the sampler needed. We convert that into the texture needed, but instead of binding the texture, we bind nothing. So what I'll do is I'll highlight this whole switch case block, and then hit Control F, and then we'll limit the search to this selection, and we will search for texture inside of there, matching whole word and case, and that selects only the textures that we are passing into GL bind texture, and we can now replace all of those with 0. And Alt Shift F to reformat. So perfect. So now we've got, no matter what kind of texture is in the slot, we are unbinding the slot. That was complicated, but I guess that's how it is. Cool. And so now at this point, after this entire loop is gone through, after we've gone through this entire loop, every slot will be unbound. We just need to bind or make the 0th texture slot active, so that way when we load our next game project, the first texture slot we use is indeed 0. It'll be like that. Cool. Awesome. And then when we start up on the next project, we will start by binding in texture slot 0. Perfect. I think that's that. It looks like I've got some red squiggles. What's that about? Incomplete type not allowed. Oh, I need to include the runtime header. Enterprise runtime.h, like that. And it looks like that's all of the errors in the document. So the squiggles should resolve in a second. No, won't you? Incomplete type not allowed. It's totally a complete type. Sometimes IntelliSense is just really slow. Let's refer to text handle out. Why is this one undefined? No, that's totally defined. Oh, it's not defined here because I copied and pasted it from somewhere else that used a different variable name. So that has to be texture. It does seem to think that the runtime members are not available. I'm gonna ignore that error and assume that it'll go away when I hit compile. But yeah, everything else seems to be okay, so let's press F7. If that's a real error, we should be seeing something in the output soon. Okay, build finished with Xcode 0. There were warnings though. Extra tokens at the end if directive. Oh, I forgot to do / to comment out the yeah. So that warning should go away now. Cool. So that's that. Just confirm that nothing breaks. Quit. Okay. That seems to have run fine. Play an editor, and then stop and file close project. We are still dealing with the same warning from shaders.cpp. But other than that, the thing still closes correctly, and I think we're in good shape. All right. So that leaves us with back to this list. We've now officially done everything except for the shader.cpp cleanup. That's gonna be complicated. And I think that this is the only part that I'm going to do offline, because it'll be very disjointed if I have to narrate everything. Like it'll be hard for me to narrate intelligibly while I'm working. But basically, I'm going to need to go through, make sure that all of the shaders that are compiled during Plan Editor are uncompiled or deleted. So that way, each time you start and stop Plane Editor, you can't accidentally just swell up, have a memory leak because you're compiling and adding more and more programs to OpenGL. That's a no-go, so I got to make sure that cleans up correctly. But after that's done, I think that we're off to the races. I'll need to do some profiling to make sure that there aren't any memory leaks when you go to open and load projects. But after that, we're going to be looking at actually doing fun stuff in the editor. So that would be things like the scene view, which has currently got nothing in it. We've got the game view, which, play a game, and that's exciting and fun. But behind it, let me move that over here. Behind it, we've got this scene view that has nothing going on. And this is where you would add the controls and the widgets and all the things to place and edit entities in your scene, and then save that out as a scene file. So that probably will be the next big project. But I gotta finish this memory cleanup stuff later before I can do that. So cool. I think this is a good place to wrap up. Thanks for joining me. You all have a great rest of your day. Oh, hey, Dorothy. You caught me at the very, very end. If you need high quality, yeah, that's all right. That's all right, Mr. Bot. Take it easy.